Aston Martin's new Honda engine has officially cleared the March 1st homologation deadline, but the truth is far more dramatic than an early sign-off. Honda pushed development until the final possible moment, then suffered battery failures, violent vibrations, repeated retirements, and warnings that the steering wheel could cause long-term damage to the driver's hands. Now, after emergency work at Honda's Sakura facility, Fernando Alonso says the vibrations are gone. That means Aston Martin may have finally removed the failure destroying its season. But if the latest electrical problems are connected, Honda may have locked Aston Martin into a crisis it cannot redesign its way out of. Subscribe to the channel. To understand why this development matters so much, you have to begin with the deadline that shaped the entire Honda project. March 1st, 2026. That was the official homologation deadline for every new Formula One power unit. Mercedes faced it. Ferrari faced it. Red Bull powertrains with Ford faced it. Audi faced it. And Honda faced it. No manufacturer received a special early approval. No one was given a secret advantage. And Honda did not complete its engine comfortably ahead of the others. According to the source, Honda continued developing until the final possible moment. That detail changes the entire story, because an early sign-off would suggest confidence. A finished design. Extra preparation time. A manufacturer arriving at the deadline with room to breathe. Honda arrived with no such comfort. It pushed until the clock almost stopped. And once the season began, Aston Martin discovered why that lack of margin mattered. The new power unit did not simply struggle for speed. It began creating reliability problems serious enough to destroy races. Battery failures appeared. Severe vibration spread through the car. Electrical systems came under pressure. And the drivers began feeling the consequences directly through the steering wheel. This was not the clean beginning Aston Martin had imagined. It was an emergency. And the reason the emergency became so difficult to solve lies inside the new engine regulations. The 2026 Formula One power units placed far more responsibility on electrical power. The motor generator unit connected to the turbo was removed. The electrical motor linked to the rear axle became dramatically more powerful. Its output increased to roughly 470 brake horsepower. The combustion engine produced around 540 brake horsepower. That meant the electrical side was no longer a small supporting system. It had become nearly as important as the combustion engine itself. And that placed extraordinary pressure on the battery. The battery had to release huge amounts of power. It had to recover energy under braking. It had to survive extreme temperatures. And it had to keep working while the car hit curbs, changed direction, and vibrated violently for lap after lap. Imagine asking a normal phone battery to power your entire house. Then imagine shaking it constantly while it does the job. That gives you a sense of the challenge. Honda was not only trying to build a powerful engine. It was trying to build an electrical system strong enough to survive conditions that no road car would ever experience. And something inside that system was not behaving properly. The source points towards severe mechanical vibration as one of the central problems. Those vibrations were not staying inside the power unit. They traveled through the chassis. They moved through the steering column. They reached the battery and control systems. And eventually, they reached the driver's hands. That is where the situation moved beyond normal performance concerns. A slow engine costs time. An unreliable engine causes a retirement. But violent vibration can attack the entire car at once. It can stress sensitive electrical components. It can loosen connections. It can create heat. It can make the steering feel inconsistent. And it can physically hurt the driver. Adrian Newey reportedly warned that prolonged vibration through the steering wheel could risk long-term nerve damage to the driver's hands. That was not a dramatic complaint. It was a safety warning. Imagine holding a powerful machine that shakes without stopping. At first, the sensation feels uncomfortable. Then your hands begin to tire. Then numbness appears. Now imagine experiencing that while controlling a Formula One car at enormous speed. You are braking at the limit. You are making tiny steering corrections. You are managing energy deployment. You are protecting the tires. You are communicating with the team. And the steering wheel is sending repeated shocks into your hands throughout the entire race. That affects more than comfort. It affects precision. It affects concentration. And most importantly, it affects trust. A Formula One driver must believe every movement from the car, every vibration, Every change in grip. Every small reaction through the steering wheel. If the car begins sending violent or confusing signals, the driver cannot attack with complete confidence. And without confidence, lap time disappears. But here is the part Aston Martin feared most. The vibration may also have been connected to the battery failures. Mechanical vibration can repeatedly stress electrical parts. Connections can weaken. Internal components can be damaged. Sensitive systems can fail after thousands of repeated impacts. Think of bending a paperclip. One bend does not break it. A second bend may not either, but bend it again. And again. Eventually, the metal weakens. The same principle can affect components inside a racing car. Not in the same simple way, but through repeated stress. And if the vibration occurs at the wrong frequency, one small weakness can become a complete failure. That may explain why Aston Martin's early problems felt connected. The car was not only shaking, the electrical system was also failing. The battery was under pressure. The drivers were suffering physically, and the team could not be certain whether it was dealing with several separate problems or one deeper problem spreading through the entire machine. That uncertainty made the crisis far more dangerous. A single failed part can be replaced. A system-wide vibration problem is much harder. The engineers must find where the vibration begins, how it travels, which parts amplify it, which systems are most vulnerable, and whether the chassis and power unit are making each other worse. Honda could not solve that problem alone. Aston Martin could not solve it alone either. The power unit and the car had to be treated as one complete system, and the opening races proved how urgent that work had become. In Australia, Fernando Alonso retired after only 15 laps. The radio message was direct. Stop the car, we have an issue. Lance Stroll also suffered engine-related problems and finished unclassified. That was the first warning. One race. 2 cars affected. And a new partnership already under pressure. But early season problems can happen. New regulations create surprises. New power units expose weaknesses that never appeared in simulation. Every manufacturer expects difficult moments. Then came China, and the situation escalated. Stroll retired after only 9 laps with a suspected battery failure. Alonso continued longer, but the vibrations became so severe that he said he physically could not continue much longer. He retired around lap 32. 2 cars. 2 retirements. 1 suspected battery problem. 1 driver physically struggling with the vibration. And Honda's response was unusually blunt. There was no excuse. That choice of words mattered. Manufacturers normally speak carefully after a failure. They say the issue is under investigation. They promise to review the data. They talk about lessons. Honda removed the protective language. There was no excuse. That statement revealed how serious the disappointment had become. The engine was not performing at the level Honda expected. The reliability was not acceptable. And Aston Martin's new era was already turning into a crisis. But the next race made the problem even harder to understand. At Suzuka, Alonso finally completed his first full race distance of the season. That should have felt like progress. Instead, he finished 18th. The car had survived. It had not competed. And Stroll did not reach the end at all. He retired on lap 30 with a water pressure failure connected to the combustion engine. That was described as a new failure mode. Those words should concern any Formula One team. A known problem can be studied. A known problem can be reproduced. A known problem can be attacked with a specific plan. A new failure mode means the list is growing. First, the battery. Then the severe vibration. Then the physical strain on the drivers. Now water pressure. Aston Martin was no longer chasing one weakness. It was chasing an entire chain of failures. And every new failure took time away from performance development. That is the hidden damage of poor reliability. A race is not only an event, it is also a test. Every completed lap gives engineers information. They study tire wear, battery temperature, energy recovery, fuel use, gearbox behavior, balance changes, cooling demands. But a car that stops early cannot complete the experiment. The team loses the most valuable data. It is like trying to understand how long a battery lasts after using it for only a few minutes. You can make predictions. You cannot see the entire cycle. Aston Martin needed full races to understand the car. The car kept failing before it could provide those answers. And while Aston Martin was stopping, its rivals were learning. Mercedes collected data. Ferrari collected data. Audi collected data. Red Bull powertrains collected data. Every finish gave them another layer of understanding. Aston Martin was losing more than points. It was losing development time. That is why the gap before Miami became so important. Aston Martin and Honda used the extended brake to attack the vibration problem directly. A car was sent to Honda's Sakura facility in Japan. That decision showed the scale of the emergency. This was not a small software correction. Honda needed to study how the power unit behaved inside the actual Aston Martin chassis. The engineers needed to understand where the vibration began, how it traveled, where it became stronger, which components were absorbing it, and whether the car itself was amplifying the problem. The engine and chassis could no longer be treated as separate. Honda built the power unit. Aston Martin built the car around it. If the engine produced a vibration, the chassis could carry it. If the mounting points reacted badly, the force could spread further. If the battery sat in a vulnerable position, repeated stress could damage it. The team could blame Honda. Honda could blame the installation, but blame would not finish a race. Both sides had to solve the complete system together. And by Miami, Aston Martin finally received the first clear sign that the work had produced something real. Alonso was asked about the vibration. His answer was simple. It's gone. He repeated the point. He would say it was gone. Those words may have been the most important update of Aston Martin's season. Not because the car suddenly became fast. It did not. Not because Honda suddenly had the best engine. The source does not support that claim. The importance came from the process. A serious problem had been identified. The drivers had described it. Newey had warned about it. Honda and Aston Martin had studied it together. The car had been taken to Sakura, and the driver could finally feel a clear improvement. That is how a strong Formula One development process is supposed to work. Problem. Investigation. Solution. Confirmation. Miami became Aston Martin's first completely clean weekend of the season. Alonso and Stroll completed both the sprint and the Grand Prix. They finished 15th and 17th. Those positions were poor. But after the retirements in Australia, China, and Japan, finishing every major session mattered. The cars survived. The engineers collected full data. The drivers experienced the power unit over race distance. And Honda received evidence that the vibration work had made a difference. For the first time, Aston Martin could begin looking beyond immediate survival. But that is where the next problem appeared. Fixing the vibration did not fix the entire car. It only revealed the next weakness. Alonso described the gearbox behavior as almost impossible to drive. That meant the violent shaking may have disappeared, but the car still did not respond predictably. And unpredictability destroys confidence. Imagine pressing the accelerator in a normal car. A little pressure gives a little acceleration. More pressure gives more acceleration. The response feels smooth. A Formula One driver needs that same relationship, but with extreme precision. At the exit of a corner, the rear tires are close to losing grip. If the power arrives too aggressively, the car can slide. If it arrives too slowly, acceleration disappears. If the gearbox reacts unpredictably, the driver cannot plan the next movement. He begins waiting for the car. And a Formula One driver cannot be fast while waiting. That costs time everywhere. It creates hesitation. It weakens confidence. So, Miami delivered two completely different messages. The first was hopeful. The vibration appeared to be under control. The second was much more serious.